Hello friends, welcome to my channel. Let's have a look at problem 695 together again. Maximum area of island. So in this video, we're going to share a solution using traversal algorithms. So here we are going to present breadth-first search. So in the previous video, we presented a solution using union find or disjoint set data structure. So both the method here and the union find method are very natural to this problem. So first, let's look at the statement of the problem. So this problem requires us to return the maximum area of island in grid. If there's no island, return 0. So the area of an island is the number of cells with a value 1 in the island. So in example 1, the return is 6, and the size and the corresponding island is depicted by the orange, deep orange color here. Example 2 is a special case. There's no island, so the return is 0. The constraints about this problem is as follows. The size of the grid characterized by m and n. And so these two numbers are both bounded above by 50. So 50 is not a very large number here. So the grid is a binary grid. In other words, it's either 0 or 1. So with that said, let's look at the method here. So the method here is breadth-first search. So the idea is the following. So we use breadth-first search to form all the islands. So in practice, we could record both the coordinates and the number of ones in an island. In other words, the actual island represented by the coordinates and its size. So for example, for this island, the size is 4, and the coordinates is given by this set here. So second, we're going to use the previous located island to avoid repetition of traversal, and we compare the island size. So that's the whole idea. So the plan is as follows. We're going to implement a breadth-first search function and then do the traversal. So here the breadth-first search function is in iterative format. In order that we can understand the finer detail of the procedure. So notice that for breadth-first search, the corresponding container is queue, and for depth-first search, the corresponding container is stack. So with that said, let me share the code first. So we are going to do two steps. First is a breadth-first search hyperfunction. So for this, let me first track the information for the size of grid. So the rows and the columns. That's it. So now we are ready to implement the breadth-first search function. Let's call it BFS. So it accepts two arguments which forms a coordinate. For this, first I'm going to introduce a variable called result, whose final state is what we want to return. It represents the size of the cluster containing this ig coordinates. So for breadth-first search, we're going to use queue. So here I'm going to use the deck container from the collections library to mimic the queue behavior. So we are going to initialize the queue, which is a deck. So here initially it contains this coordinates from the arguments. So now we introduce a set to aid our traversal. So here the set visited is going to be the coordinates site for the island. In other words, it represents the island. So below is a standard while loop. So first we're going to track the coordinate information. See, RC equals Q pop left. So we're going to use the left as the head and the right as the tail. Then we are going to check if this coordinate RC is visited or not. If it's not visited, then we're going to add this coordinate to visited. So in other words, visited, add this coordinate. Then we're going to enlarge the size by 1. After these two operations, we're going to check the neighbors for this coordinate RC. So what we're going to do is for xy in the neighbor of this coordinate RC, that is r minus 1c, r plus 1c, r c minus 1, and r c plus 1. So these 4 neighbors may or may not inbound. So we need to make sure the corresponding coordinates are inbound. So we're going to check if 0 less or equal than x less than m, and 0 less or equal than y less or equal to m. And if we want to traverse this grid, its value should be 1. And also xy shall not be in visited. So if this is the case, we are going to include this coordinate. Let's see, append this x and y. So that's the whole procedure. So here what we want to return is the size of the island and the coordinates representing the island, so visited. So that's it for the hyperfunction. So now we are going to form all the possible island for this grid, and then compare the size. So this is actually very standard now. So before we do that, we actually can print out this BFS. Let's see for this position. Then we are going to get this island right here. So 4 is the size, and this 4 coordinates in the set represent the island itself. So with that said, let's do the procedure. So first I'm going to introduce a variable called result and a set called visited. And then we are going to do the traversal for I in range M, for G in range N. So we are going to check if grid IG equals 1. So if this value is 1, it's a candidate to be traversed. And then we need to check IG not in visited in order to avoid repetition. So if it's not in visited, then we are going to call BFS, right? The return is a size, let's call it a temporary variable, and the set representing the island. So let's call it BFS IG. Then we are going to compare the result state with the current island size. That is, result equals max result and the temp. And then, so after we get this island, so all these coordinates in S are visited. So we're going to enlarge this visited site by union with this S. That's all we needed to do. Then afterwards, we are ready to return the result. So that's the full solution for this problem in the current format. So let's do a special case check. Yeah, it passes a special case. Now let's do a generic case check. So in range, also here I wrote less than. Yeah, it passes the generic case. I guess for the code part, that's it. So now let's look at the questions. First, actually it's good to compare the solution here with the union find solution in the channel. So actually, we feel that these two methods are essentially the same. So even if we compare the formats of code. So this is the one. And another thing is that it's good to try writing a recursive solution to this problem. That's also good to have a try. So with that said, I guess that's about it for this solution and for this video. Thank you very much.